Hello students, welcome to the Veritas Preparatory Lecture. Here we cover the softwares and basic data analysis techniques you will need to succeed throughout this class and beyond. Today we will introduce the Veritas AI softwares. We'll then cover a tutorial for Jupyter Notebooks using Google Colab. We'll also cover a tutorial on the basics of Python. And lastly, we ask you to take an assessment quiz in order to understand your level of Python and machine learning. The Veritas AI softwares includes Python. In addition, we use Jupyter Notebooks to write our code, and we rely on very important packages such as scikit-learn and TensorFlow in order to build our machine learning models. We also use pandas and NumPy to manipulate our data, and we use Seaborn and Matplotlib in order to visualize our results. So a little history on the Python programming language. It was first developed in 1991 by Guido van Rossum. He actually named it after his favorite British TV show called Monty Python's Flying Circus. Since then, Python has developed into version 3, and many different companies use it in order to analyze their data sets. So in order to write Python code, the Veritas AI class relies on Jupyter Notebooks, but I'd like to start with what a Jupyter Notebook is not. So traditional code editors cannot visualize data. Here, for example, we have this nice software where you can see all of your code. It's color-coded, so you can try to understand what the different sections are. However, at no point in time can you really see your visualizations that are generated by your code. Jupyter Notebooks, on the other hand, allow you to write your code and use that code in that very moment to visualize, such as you see here. So it's much more data-centric, and you can see how it'd be useful for machine learning. So in order to understand Jupyter Notebooks, we'll now cover the tutorial. Go ahead and please click on the link here to access Colab. Google Colaboratory offers many resources in order to run Jupyter Notebooks and Python code. Please click on this Open Colab button here. From here, we can see this nice menu where we can find many of our previous works that we've done before. To get started on a new notebook, please click this plus new notebook button here. What you can see now is that it loaded this new page where we can see the title or the file name of our Jupyter Notebook. Currently it's called Untitled 0. Go ahead and delete that and we'll call it test. The extension for Jupyter Notebooks is typically period.ipynb. So often we'll actually ask you to make a copy of a Jupyter Notebook, which you can do by going to File, Save a Copy in Drive. For now, we can skip this step. So the first thing you'll notice is that we have this gray box here that says Start Coding or Generate with AI. You can start coding some simple things such as print, hello, Veritas AI. However, we need to run this code somehow. That's where the play button here comes in handy. Go ahead and click play. So we just have to wait a little so that it gets connected to the servers. But once it does, it'll run our code and we'll see below, hello, Veritas AI. Now you can add additional code blocks or code cells, as we call them, by either hovering over here, adding one below. You can hover over here and adding one above. Or you can also click the plus code here, and you can start typing away your next Python code. And again, you can either run by clicking here, or you can also use the button combination Control-Enter or Shift-Enter, which will run the code and take you to the next code block. In addition to having these code blocks or cells, you also have text blocks. Let's go ahead and try to add one. And what you'll see is a slightly different menu here. You can start typing a message such as, I am analyzing my data, and you'll see a small preview of your text over here. Like before, you can run this code block by typing either Control Enter or Shift Enter. Sorry about that. And what you can see is just a generic message, but you can actually use it for writing different types of messages that might be helpful for you in your analysis. You might also find it useful to use these code blocks to actually break your code apart into different sections. You might say something such as load data. And you'll see that I added the hashtag here that makes it into a title. And you'll see again the small preview here. I'll click Shift Enter. So I might load my data here. I might also do another thing such as analyze variables. Shift Enter. And this is quite useful because now what you have is over here on the left side, you have this nice table of contents where you can see your different sections. By clicking on them, you're navigated over to them. You can also click here to hide or expand the code just beneath. So you can see how that can be quite useful. In addition, each of these code blocks also has this menu here where you can delete and have a few additional functions, which I'll let you cover on your own. In addition to these functions, I just want to walk you through one more important menu, which is called the runtime menu. Here you can find options such as run all, run before, run selection, run cell, and below. These are all functions that allow you to run your code. Particularly, let's try run all. This is quite nice because it'll run all of the code cells that you have. You can also restart your session, which can be important when you create many variables and sometimes when you're overriding the values of variables. You can also restart the session and run all. Go ahead and give that a try. I'll restart the session and I'll rerun. There's many other functionalities that you can try at your own leisure. And with that, this ends the tutorial to Google Colab and Jupyter Notebooks. Next, we will move on to our Python tutorial. Please go ahead on the link walkthrough0.ipynb to access it. Before we begin, please go ahead and click on File, save a copy in Drive, so you're able to add and experiment with your own code as you wish. With that, welcome to the Veritas AI Python Bootcamp. Python is known as a scripting language that allows for quick code development and has recently been used extensively for data analysis and machine learning. This primer will help students who have little to no exposure to Python, and it can serve as a refresher for those that have had some previous experience. In case you want to jump around, please go ahead and take a look at the table of contents so you can see what content you might already be familiar with and jump over to new content. With that, we'll cover basic data types and variables. Python allows you to handle a variety of data types. Letters or words are stored between single or double quotation marks, such as below. Numbers can be stored as either integers or numbers with decimals called floats, as shown here. In order to store these values within our coding session, we can use variables by using the following syntax. Here, for example, we write MSG, or short for message, equals quotation mark, how many pizzas do you want? Quotation mark. And also we can store num underscore pizzas equals 10. Now these variables can be used for a variety of manipulations. In the case above, you can try printing the values together. Go ahead and run the code cell below. Now you can see that the print command here or function will first print message, how many pizzas do you want, followed by number of pizzas. One other common data type we will mention are booleans. These are used for logic-based manipulations using true or false. Run the following to see our preview. Again, we see our print function will print our message, is Paul still hungry, followed by our answer, false. Next are larger data types. The basic Python ecosystem includes a variety of larger data types. The first we will introduce is a list. Lists are able to store however many values you want of any type. Here's an example. We type L is equal to square bracket, the number 1, the number 2, the word jump, the word run, and a few booleans, true and false. Go ahead and click play. To access individual values of a list, you index using square brackets as follows. You'll type the name of the variable, L bracket 0 will allow you to access the first element. You can do the same with the fourth element using the index 3. To get the last item, you can either use the number 5, indicating the sixth item, or -1, which will go backwards. Let's go ahead and try that. You can see L bracket -1 gets us our false. Note L bracket -2 will get the second element starting from the right. So -1, -2 would give us true. Next are dictionaries, or for short we use dict. Dict, like a list, is able to store any number and any type of value. In addition, dicts are able to use a system of key and value pairs in order to create access to data via this key. So here's an example, and the syntax we use, we'll type D is equal to curly brace, then we'll use this key here, which in this case is a string, and then colon followed by the value, which in this case is another string. So question 1, how many pizzas do you want? The next key value pair is A1 or answer 1 colon 10. Then from there we also have question 2, is Paul still hungry, followed by answer 2, false. So to access individual values of a dict, you index using square brackets as follows. D bracket Q1. Let's go ahead and run this one first, then this one. How many pizzas do you want? Then we can print both the Q1 and QA1 together. How many pizzas do you want? 10. And we can do the same for question 2. Is Paul still hungry? False. These are the main data types in Python. A few others exist which are very important, such as a set. For more information, check out the resources linked in the presentation. Next, we'll cover for loops, which allow us to iterate through large data types. For loops are a great tool to repeat a piece of code that will act on different elements of a list or dictionary. Here, for example, this basic syntax is typing for, the name of the variable that will capture each element. In this case, I'm using x in L. So if you remember, L is a list, so each element of the list will be passed in as x. So if we type 4x in L, print x, we will print each of those elements. In addition, values of a list can actually be changed within a loop, so you can try to do really interesting things, such as here we define a list with the numbers 1, 2, 3. If we cycle through that list using for I in range len numbers, in this case, we're cycling through a list, the indices of this list, then we can use this plus equals to add to that list. Similar operations can be done with dictionaries. In this case, when you type 4K in D, you're actually cycling through each of the keys. Then we can access each of the values as we did before. For K and D, print D square bracket K, the key. and we'll print each of those things. For dictionaries, we have this additional function that's called d.items parentheses, which allows us to get both the key and the value using the syntax. So go ahead and try that on your own, and you can try various different operations. Next, we'll look into using logic to direct certain operations. Often, we want our code to take certain actions only if certain conditions are met. This is where logic operations come into play. For example, you might have medical data where you have to decide whether a patient has high blood pressure or not. We know that a blood pressure of 120 milliliters of mercury or lower is healthy, and anything higher is considered elevated. Let's say we have patient A with 116 milliliters of mercury and a patient B with 132. You can then make code to encapsulate and determine high or low blood pressure. To do this, we will use if, elif, and else statements which follow the following syntax. We build it by writing if with a condition, then we do X, Y, or Z. And then else, and we do alpha, beta, gamma. We can make much more complex logic using if, condition 1, do this. Elif, condition 2, do this too. Elif, condition 3, do this 3. And lastly, else, do 4. Let's see how this code will work for our blood pressure scenario. Patient A has a pressure of 116, and we can build our if statements by saying if patient A has less than 120, then please print that the patient has a low blood pressure. Else, we can say please make it that tell us that patient A has a high blood pressure. Let's try running this code. When this runs, this statement is evaluated and the first print statement is used. Now for patient B, their blood pressure is elevated, and so this first if statement will not be satisfied, and instead we'll go to the second statement we have. Let's give that a try. And we see that now we have patient B has high blood pressure. So there's various different levels of state. You can make many different levels of conditions to meet many different cases that you might be considering. This is just an introduction, and there's much more to try out. Now we'll be looking at utilizing libraries to access additional functions. Libraries are powerful extensions to the Python coding ecosystem that allow you to access additional functions developed by experts in machine learning, visualizations, and much, much more. As mentioned in the lecture, we will focus our attention on the following libraries: NumPy, Pandas, scikit-learn, TensorFlow, Matplotlib, and Seaborn. You will see combinations of these being used across our lecture. To load a library, you will use the following syntax: import NumPy, import Pandas, import sklearn, and this includes the others. You will also see slightly different syntax that allows you to give nicknames to your libraries. The syntax for this part is import library as nickname. This is common for libraries such as NumPy, Pandas, TensorFlow, and Seaborn. You will often see the following nicknames: import NumPy as NP, import Pandas as PD, import TensorFlow as TF, and import Seaborn as SNS. In other cases, libraries are really large and smaller subpackages can be loaded individually. This is what it looks like for Matplotlib's pyplot subpackage. Import matplotlib.pyplot as plt. We'll go ahead and run all of these previous code cells. Notice a nickname was also used for this last case. Next, we will teach you some basic data loading, manipulation, and visualization with some of these libraries. But right before using these libraries, we'll link the Veritas AI datasets that are necessary for this class. This class relies on a few publicly available datasets, which we have gathered for your use here. Before continuing Lecture 0 and future lectures, please make sure to complete the following steps. 1. Click on the link above. 2. Right-click on Veritas AI dataset. 3. Hover over Organize. 4. Left-click on Shortcut. 5. Find My Drive and left-click on Add. And 6. Close the tab. I'll do that here for your reference. This will create a shortcut to the Veritas AI dataset for both projects and walkthroughs within your Google Drive. Caution, if you do not shortcut directly to My Drive, many codes will not work. Please double check to see if this link here contains a link to the Veritas AI dataset. Let's take a quick look. And you can see here we have Veritas-AI-data. Code walkthroughs and projects will use this shortcut to access datasets. For your general information, your Google Drive is mounted in all of our codes using the following code. So this here from google.colab import drive will mount this data. Go ahead and click this now to see how it works. This will ask for permission for this notebook to access your Google Drive files. This will happen every single time you open a new notebook that's trying to mount. Go ahead and click Connect to Google Drive. From here, select your Veritas account. Click Continue. And continue one more time. And now your data has been mounted. Your data will then be available at the following path: /content, /drive, /my drive, /veritas-ai-data. Run the cell below to see a list of files. And here you can see all of those files. If the code cell above runs and you see a list of files, then you're ready to begin your Veritas AI journey. Now we can try loading and manipulating data with pandas. Data can come in many different files, types, and sources. Some common file types include tab-separated files, comma-separated files, Excel, JSON, and many more. These files can easily be opened and explored, but other data types are compressed or specialized, such as gzipped, pickles, parquet, and much more. We will mainly focus on the use of CSV files across this class. To begin working with data, we will look at the California housing data. Pandas provides us a way to load information by using df equals pd.read table, parentheses, file path. In the code above, you simply replace file path with the location of your file. Let's try that next. So here we have file name is equal to, and here's the path I described before with our shortcut to our Veritas AI data, and we have California_housing_train.csv. This is saved into a variable and is now passed over to pd.read table. We also provide the sep equals parentheses comma to indicate that this data is comma separated. Go ahead and run the code cell. Now that we have loaded the data, we can take a glance by using the df.head function. This function will load just the first 5 rows of your dataset. The Pandas package and its data frames are great tools to use for your data analysis needs. Now that you have your data ready, the next most important part is to learn how to manipulate your data. There are a lot of great tutorials out there. Here we've discussed some important data access and manipulations you will need throughout the Veritas AI classwork. We start by extracting data with iLock. Pandas has two main methods to access your data. The df.ilock method is a powerful way of using numbers to specify the data that you would like to access. To access a single row, you can use df.ilock square brackets int. For example, df.ilock 0. This will extract the first row. df.ilock 1 will extract the second. The previous syntax focused on a single row, but things start to get interesting when you start accessing columns as well. Pandas uses the df.ilock square bracket rows, comma columns to access specific rows and columns. Often you need to access all rows or all columns. Therefore, Pandas allows you to use the colon to ask for entire rows or columns. This comes in handy when you need to access a subset of rows, but all columns or vice versa. Putting all of this together, we can access the data for a given column using the syntax df.ilock square bracket colon comma int. For example, try running this code block here. df.ilock square bracket colon will extract all the rows, comma 0 will extract just the first column. The next logical step would then be to extract the value of a single cell. This is possible by specifying I'll just clip it out. The next logical step would then be to extract the value of a single cell. This is possible by specifying values for both the rows and columns like so. We use df.ilock square bracket 0, comma 0. When we run this, we get a single value. There are other methods of extracting data. In particular, we'll use .lock. In many cases, your rows and columns will have names associated with them. In Pandas, this can allow you to access rows and columns by using their names. For the California housing dataset, we have the following row names. In this particular case, they're just integers. Note, row names are stored within the index attribute. What you'll notice about the row names is that they are just a sequence of numbers, as I mentioned earlier, but now let's look at columns. We can look at columns by using df.columns.toList. You can see that columns have names which we can use to access column values. Let's try that next. The syntax looks like this. We write df.lock square bracket. You see again we can use colon to access all the rows, comma, and then we write out as a string the name of the column. And now we have the data just for longitude. From time to time, we have to generate new columns. Sometimes you need to add these or generate these from existing columns. This is quite common, and there are several functions in Pandas that can help you accomplish your goals. Here, we will try a very simple example. Let's say we think that median house values is wrong due to a miscalculation, and we need to add back $10,000 to the median house price. We can do this easily. The syntax is as follows. We write df.loc square bracket colon, comma, median house value, bracket plus 10,000. And when you run this, you now see a similar data frame column with that added value to each of the median house values. To then add this new column, we can do the following. We write df.loc square bracket colon, comma, median house value corrected, bracket is equal to our previous code. So let's go ahead and run that. Now you see that this new column has been added to the rightmost column. So let's run this, and when we just take df.head, we see that that value is here, and here's the original value. As you can see, Pandas provides many functionalities that make it a powerful tool for data analysis and machine learning. Now we can move over to understanding NumPy and its connection to Pandas. Pandas is a package built on NumPy arrays, therefore there's a lot of compatibility between the two. From time to time, machine learning algorithms use NumPy arrays directly, and thus we will briefly describe functionalities of NumPy that are important for our class. To access the NumPy array behind Pandas, you can use df.values. And this is what the array looks like. NumPy arrays only use integers to access rows and columns. This is similar to the iloc method for Pandas data frames. To access the first row, we can use df.values bracket 0. To access the first column, we can use df.values bracket colon comma 0. To access the first cell in the first row and column, we use df.values 0 comma 0. In machine learning and linear algebra, arrays are known as vectors. Vectors can be either in horizontal or vertical format, with vertical being the most common and preferred format. When extracting a NumPy column, it is returned as a horizontal vector as shown below. To convert this into a horizontal vector, NumPy provides the dot reshape, comma, sizedim1, comma, sizedim2, comma, dot, 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 comma, sizedim_n function. In particular, we can reshape a table with rows and columns using dot reshape -1, comma 1. -1 instructs the function to use as many rows as needed, and 1 specifies that there should be a single column, thus forming a vertical vector. And we'll try that out here. And now we see that the formats are really different. Here the vector is in a horizontal fashion, whereas here it's in a vertical. This might be confusing at first, but with this introduction, you can be aware of the use of NumPy arrays throughout our class content. And now we move to a slightly more fun part where we can finally generate plots using Seaborn. Seaborn is a plotting library that is growing in popularity due to its simplicity and ease of use. It is built upon another popular package known as matplotlib. Here we will try out visualizing histograms as scatter plots. For the California housing data set, we are most interested in the median house value. Therefore, we are really interested in the distribution of this variable. To plot using Seaborn, we'll use the syntax sns.histplot parentheses your data frame, comma, x is equal to some numerical column. And we can use the code as follows. sns.hisplot, comma, df, comma, x equals median house value. Go ahead and try that out. And now we can see this nice distribution where most of the house values seem to be around 180,000. Scatter plots are another important visualization where you can examine the relationship between two numerical variables. The Seaborn syntax is sns.scatterplot, parentheses, your data frame, comma, x equals column 1, and y equals column 2. This time, we're going to plot median income versus median house value to see if there's some pattern between these two variables. So go ahead and run this. And you can see that there appears to potentially be a pattern with this data increasing from left to right. So now that we've seen how Seaborn works, we can try to also understand matplotlib and its connection to Seaborn. Like the connection between NumPy and Pandas, matplotlib is the foundation for Seaborn. Given this, there are a lot of compatibilities between the two. Here we will show you code where they cooperate to generate more details and customized figures. For the next code, we will rely on the matplotlib pyplot subpackage. Go ahead and import this. First, we'll create a figure and axis objects that are the underlying drawing mechanisms behind plotting of the histogram. The axis object can then be passed into sns.hisplot. Finally, the axis object can be used to update other items such as the title, x-axis label, y-axis label, and much more. So here we'll go ahead and run this code where we first create these figure and axis objects with the plt.subplots. This axis object is then passed into our hisplot, and then that axis object can then be acted upon using functions such as setTitle, that will add this title here, set underscore x label, that can add this x label here, and similarly set underscore y label. Go ahead and give that a try. So you can see that there's lots of important cooperation between these two packages. This marks the end of Lecture 0. Although this class is focused on machine learning and data science, it is really important you keep practicing your data access, manipulation, and visualization skills so that you can focus your class time on machine learning techniques and theory. For other resources, please visit 10 Minutes to Panda, here, W3 School, Pandas Tutorials, Getting Started with Pandas for Data Science, and Community Tutorials. Happy data analysis and modeling. So that brings us to our quiz. Please take your time to complete the quiz to provide your answers. Please don't use any outside resources, just whatever you've learned through this class and whatever you know from before. Here's a quick look at what the quiz looks like. Please provide your email, your first and last name, and go ahead and answer these questions to your best of your ability. So we leave you with just a few resources to learn a little bit more about pandas, more about the packages we'll be using, and a few FAQs in case you're a little interested in what Jupyter is and if it's required, and other such cases. Thank you, and we'll see you at lecture number 1.